والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. And we are in section 6.5, and we finished the first objective, which is solving equations with one trigonometric function. And now we will solve equations with multiple angles. And by multiple angles, we mean 3x, multiple of 3, x over 2, multiple of half, 2x, x over 3, 4x. So the angle is not x, it is a number times x. Let us see how to solve such exercises, such examples. First example, solve this equation. Tan 3x equals to 1. X is between 0 and 2 pi. First thing you need to do here is to find the range. When he says, notice that here he says 0 to 2 pi. So he needs only the solutions of this equation, if it is tan x, in the first revolution. But this is for x. What about 3x? So the first thing is to multiply this inequality by 3. So 0 times 3 is 0. X times 3 is 3x. And 2 pi times 3 is 6 pi. From 0 to 6 pi, 3 revolutions. So I'm going to search for solutions for 3x in 3 revolutions. All right. First, we find the solutions in the first revolution. The first revolution is from 0 to 2 pi. And first thing I have to find out is to solve this equation. So if you solve this equation, 3x would be tan inverse of 1. And if you use the calculator to find tan inverse of 1 and make sure that you are in radian mode, the answer would be pi over 4. So our reference angle that we are talking about is pi over 4. So we have pi over 4 here, 3 pi over 4 here, and 5 pi over 4 here, and 7 pi over 4 here. Now, tan is 1. Tan is positive. Tan is positive in the first quadrant and in the third quadrant. So I have two solutions for 3x. 3x could be pi over 4 or 5 pi over 4. These are the two solutions in the first quadrant, in the first revolution, But 3x is from 0 to 6 pi. So you don't stop at 2 pi. You continue another revolution. So to continue another revolution, you just add 2 pi. So pi over 4 plus 2 pi will be also a solution. And 5 pi over 4 plus 2 pi would be also a solution. These two solutions are in the second revolution. We need to go also to the third revolution. So I add another 2 pi. So pi over 4 plus 4 pi would be a solution. And 5 pi over 4 plus 2 pi means plus 4 pi. So these are the values. These are the solutions of 3x. I have pi over 4. I have 5 pi over 4. If you add 8 over 4, remember 2 pi is 8 over 4 plus pi over 4. This is 9 over 4. Here, 13 over 4. Okay, adding 8. Here, adding 16 over 4 plus 1. 16 plus 1 means 17. You can find this by calculator easily. 22 pi over 4. You can start by 1 pi over 4, add 8, 9, add another 8, 17. Start by 5, add 8, 13, add another 8, so it's 21. So this is not 22, this is 21. So how many solutions? 2, 4, 6. 6 solutions for 3x in the third in 3 revolutions. But when he says solve the equation, he needs the values of x, not the values of 3x. So what can I do? I can divide each one of these by 3. And remember, dividing by 3, when you divide by 3, this means what? It means you are multiplying by 1 over 3. Okay? So multiply by 1 over 3. So multiply each denominator by 3. So you will have pi over 12, 5 pi over 12, 9 pi over 12, 13 pi over 12, 17 pi over 12, 20 pi over 12. And you can check all of these answers. So why not checking, for example, 21 pi over 12? Is this really a solution of this equation? Just write 10, 3 times x. X is 21 pi over 12. And ask the calculator for the answer. The answer is 1. So this answer is correct. And you can check all of them. We have 6 answers for this equation where x is between 0 and 2 pi. Is x between 0 and 2 pi? Check. Here x, the largest x is 21 over 12. 2 pi is 24 over 12. So 21 over 12 is less than 24 over 12. So all of these answers are between 0 and 2 pi. So these are the 6 answers of this equation. Please try to do this one. And these are the answers. You have 4 answers. 2x, you have 4 answers. It is not a rule, but it happens like this here. Please check it and try to find these answers. Let me solve this one. Again, if you have a multiple angle, as soon as you have not x, you don't have x, you have something times x, your first step is to have x over 2 here. Okay, I need to find the range of x over 2. I know that x is between 0 and 2 pi, but I need x over 2. So I should divide by 2. 0 divided by 2 is 0. X divided by 2 is x over 2. 2 pi divided by 2 is pi. So you need the answers, you need the values of x over 2 to be between 0 and pi. That's half revolution. Ask the calculator to find, now what would be x over 2? It would be sine inverse of square root of 3 over 2. Ask for sine inverse of square root of 3 over 2 and be sure that you are in the radian mode. The answer is pi over 3. So our reference angle is pi over 3. So immediately you sketch the graph of the 4 angles with reference angle pi over 3. 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now what would be x over 2? X over 2 would be in the first from 0 to pi only from 0 to pi. So either pi over 3 or 2 pi over 3. But sine is positive. Okay, sine is positive here and here, in the first and in the second. So I have 2 solutions. Either x over 2 is pi over 3 or 2 pi over 3. These are the two answers for this problem. Now, I don't need x over 2. I need x. To find x, you multiply by 2. If you multiply by 2, you get x equals 2 pi over 3 or 4 pi over 3. So these are the answers of this problem. Please check your answers. Check that 4 pi over 3 is an answer, for example. So write sine and write 4 pi over 3 and then say divided by, okay? So write 4 pi over 3 and say over 2 and ask the calculator for the answer. The answer is square root of 3 over 2. So this is a solution and this is also a solution. And are you in the range? Is x from 0 to 2 pi? Yeah, x from 0 to 2 pi. 4 pi over 3 is less than 2 pi. So these are the two answers of this equation. Please try this one. And there is only one answer, which is pi over 2. Do the same steps exactly. These exercises involve equations with multiple angles. Solve each equation on this interval from 0 to 2 pi. Sine 2x, we have seen something similar. Please do it. Tan 3x, we did 3x, okay? And tan x over 2, we did something like this. Let me choose one of these to solve. Let me solve sine 2x or tan. What did we solve here? Sine, all of them. We solved one sine and one tan. There is no cosine. So anyway, let me choose this one. Let me choose this one. Sine 2x equals square root of 3 over 2. Again, I know that x is between 0 and 2 pi. From where? From here. Now I don't need x, I need 2x. So I multiply by 2. So 2x is between 0 and 4 pi. This means the first two revolutions. Use the calculator to find sine inverse of square root of 3 over 2. What is sine inverse of square root of 3 over 2? I guess it is pi over 3. So the reference angle is pi over 3. So you have this one, pi over 3, 2 pi over 3, 5 pi over 3, 4 pi over 3. Okay. Now, the sign is positive. So we are in the first and the second quadrant. So we have pi over 3 and 2 pi over 3. So the answer here, 2x is pi over 3 and 2 pi over 3. These are the two answers in the first revolution. Now, I need to go 2 revolutions because 2x up to 4 pi. So I need to add another 2 pi. So pi over 3 plus 2 pi would be a solution. And 2 pi over 3 plus 2 pi would be also a solution. And that's it, because we need to go to 4 pi. Now, 2x would be pi over 3, 2 pi over 3, and add this by calculator, or 2 is 6 over 3. So you are adding 6 to 1, getting 7. So 7 pi over 3, 6 plus 2, 8 pi over 3. So these are the 4 solutions of 2x, but I need x. So I divide by 2 or I multiply by half. So this would be pi over 6. If you multiply by half, you multiply each denominator by 2. 2 pi over 6, 7 pi over 6, 8 pi over 6. Of course, you can simplify this, write it pi over 3, write this 8 pi over 3. These are the 4 solutions. And please, when you find your solutions, at least check one of them. And usually check the last one, okay? So replace x by this one. So multiply sine 2 times this one and check the result. So sine 2 times 8 pi over 6 is just square root of 3 over 2. So the answer, your answers are correct. Good. This is the end of this objective, which is how to deal with multiple angles. Now, we will solve trigonometric equations that are quadratic in form. If you remember, a quadratic equation is AU square plus BU plus C equals to C. This is what we call a quadratic equation. Okay. Now, we will have U as a trigonometric function. So look to this equation. 2 cosine square plus cosine minus 1. It is written like this exactly. If you call cosine x u, you will have 2u square plus u minus 1 equals to 0. So we call this equation quadratic in form because you can change it to a quadratic equation by this substitution. Also here, this is a quadratic in form because if you call sine x u, you will have 2u squared minus 3u plus 1 equals to 0, and this is a quadratic equation. How to solve such equations? Very easy. You try factoring. If factoring doesn't work, you use the quadratic formula or the square root property. What is the quadratic formula? Quadratic formula says x is negative b plus or minus square root of b squared minus 4ac over 2a. This is the quadratic formula. What about the square root property? Square root property says if x squared is k, then x is plus or minus square root of k. This is called square root property. So you can use one of these two if factoring doesn't work to solve the equation. Let us do this one. What do we have? Quadratic in form equation. So you can immediately, if you want, you can try factoring. So 2 cosine square, you can write it 2 cosine x times cosine x. And you search for two numbers. No, not here. But if you put, for example, plus 1 here and minus 1 here, then minus 1 times 1 will give you negative 1. And negative cosine, positive 2 cosine plus 2 cosine would give you 1 cosine. So this is the factored form of this equation. Once you factor this equation, it's finished. Either 2 cosine x minus 1 is 0, which means cosine x is half, or cosine x is negative 1. So you have two equations, and you can solve these equations as we did in objective 1. So let us solve cosine x equals half. Using the calculator, x is cosine inverse half. Ask the calculator to find cosine inverse half. It will say pi over 3. So pi over 3 is our reference angle. Pi over 3 is the reference angle. You have to remember that we have pi over 3 and 2 pi over 3 and 4 pi over 3 and 5 pi over 3. Now, why did I choose these two? Because the cosine is positive, okay? The cosine is positive. Remember, he says solve the equation here in the first revolution only. So the solutions of this equation, x is pi over 3 and 5 pi over 3, because cosine is positive in the first and the fourth quadrant. Now what about this one? Cosine x is negative 1. Well, cosine negative 1, you find it from here. And if you remember, cosine is x. So cosine is negative 1 only here when you have negative 1 and 0. So the only solution of this equation is pi. And I'm sure if you use the calculator, if you ask the calculator to find cosine inverse of negative 1, it will give you pi, all right? But you need to know whether is it the only solution or there are more solutions. So in this case, this is the only solution. So now the solution set of this equation, we have three solutions. We have pi, pi over 3, and 5 pi over 3. All of these are solutions of this equation, and you can check them. You can replace x by pi, 2 cosine square pi plus cosine pi minus 1. See whether the result is 0 or not. Check that your answer is correct. This is the section. Here, this is the objective. Here, the same. Okay, you factor, and you have two equations. You solve them, and you will have these three solutions. Let us solve this equation. Here, we don't have, yeah, this is a quadratic equation, a quadratic in form, but it is not like this one, okay? It's not like this one. We don't have sine x, we have only sine square. So this is in the form 4u square minus 1 equals to 0. And the easiest way to solve this equation is to use the square root property. This is the square root property. So you need to solve the equation for x square or for u square. So I will solve this equation for sine square. So if you solve it for sine square x, 1 would be taken to the other side divided by 4. So you will have 1 over 4. And now using the square root property, sine x would be plus or minus square root of 1 over 4, which is half. So I have two equations. Sine x is half or sine x is negative half. And the question, what are the solutions of this equation in the first revolution? If you use the calculator to find sine inverse of half or negative half, I don't care. Okay, let us solve it for the first one. For the first one, ask for half. The answer is pi over 6. Okay, if you ask for negative half, okay, the answer is negative pi over 6. So in both cases, the reference angle is pi over 6. So you need to deal only with pi over 6 and any angle with the reference angle pi over 6. We have 4, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now, I have two equations here. One of them sine positive, so these would be the two solutions. And the other one sine negative, so these would be the two solutions. So for this equation, actually, the solution set consists of all the four solutions. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And you can check 11 pi over 6, for example. Find 4 sine square 11 pi over 6 minus 1. Check that the answer is 0. Please do this one similarly. Take 3 to the other side, 3 over 4, and you will have two equations, plus or minus, and this would be the answers. This equation you can solve a quadratic in form. Okay, this is a quadratic in form. You can do it like the one we solved. Also this one, quadratic in form. Also this one, a quadratic in form. This one similar to the last one we solved, 1 over 4, and you take the square roots. Let us solve this example because we have secant. It is the same, but let us do it. So what should we do first? We solve for secant square. So secant square x is 2. This means that secant x is plus or minus square root of 2. This is the square root property. This means that if secant is square root of 2, then cosine is 1 over square root of 2, or cosine is negative 1 over square root of 2. Now, if you ask the calculator to find cosine inverse 1 over square root of 2, it will say to you pi over 4. Okay. And if you ask the calculator to find cosine inverse of negative 1 over square root of 2, it will say to you 3 over 4. Okay. So uh, here x equals cosine inverse negative 1 over square root over 2, the calculator will say 3 pi over 4. In both cases, the reference angle is pi over 4. So we are dealing with pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, the cosine is positive, so the solutions are these two. Cosine is negative, the solutions are these two. So the solution set of this equation would consist of all the four solutions. And you can replace any one of them by x here and check that these four answers are correct and they are the answers in the first revolution. All of these questions are in the first revolution. If not in the first revolution, we have to add plus 2 in pi as we did in objective 1. Well, I will stop here and next time we will finish the last two objectives of section 6.5.